Welcome to my channel. I'm Zhangjing Xu. Let's talk about the 16th problems in chapter 2. In these problems, it tells us the position function with a time t. It looks like this one. This one. And then tell us the position x unit is meter and the time t unit in second. So meter and second is in IS unit, so we don't do any unit we don't need to convert unit. The first part, question A, asks us to determine the position of this ball at the time 1.0 second, 2 second, and 3 second. And because it tells us the position and the time t function there, so it's very simple. We just need to input the time 1 second, 2 second, and 3 second inside and do the calculation. Easy, right? The second problem asks us to find the average velocity at a time interval, a time period, from 1 second to the 3 second. So there, the average velocity is depend on the displacement divided by time taken. Their time taken is given. So we need to decide the displacement. The displacement comes from the final position minus initial position. So in this problem, the final position is this one. X at the position at time t equals to 3 seconds. Initial position is this one. Time t equals 1 second. So we can get it. The initial position is time t equals to 1. And the time t1 is 1 second. And then the final position S2 is the time t equals 3 seconds there. And then the time t2 is 3 seconds. So we just input the equations. Average velocity equals to the displacement divided by time taken. Then we are done. The third problem asks us to find instantaneous velocity. For the instantaneous velocity is we consider the time taken. This time period is small, and super small and tends to 0. And then we find it. So we can say if the delta t is very small, so this way is we consider. This is the x f, right? Minus x initial with divided by delta t. And then we take the limit. Delta t tends to 0. So delta t tends to 0. This one is called instantaneous velocity. And for this one, this equation just equal to the derivation. So we can consider this v, instantaneous velocity, is derivation of the x with the t. So we do the derivation for this function. This is constant, just drop it. And then this t with power 1, we keep it. And then a constant 1.1 times t squared. Then, so for this one, 1.1 times 2. Then t just keeps the t, right? So the instantaneous velocity is in this function. And then we input the unit at 1 second, 2 second, and 3 second. It looks like that. Now, finally, we can draw how this motion works. We can draw a function, or we can draw a picture. It looks like that this is x position and this is t. So it looks like at the initial, it is at the negative ways, right? Then it reaches to the initial, and then it goes to the positive direction. So at the beginning, it is at the negative direction, and then it reaches to the orange, and then goes to the positive directions. And also, if we plot the VT graphs, we find it just moves at a velocity with the time. So you can say this is a picture of velocity with the time t, instantaneous velocity. So at the first, it is at negative direction, then it reaches to orange and then goes to positive directions. Okay, that's all. Thank you.